All right, what's up, everyone? Week 129 of building my own operating system. Thanks a lot for joining today. So today we have an option, still kind of deciding what I want to do. Pretty much either we could go into working on setting up a timer interrupt, or we could do a little bit of a detour and explore a bit of test infrastructure. I've been wanting to do this test infrastructure stuff for a long time. I think, yeah, and then also before I get started, I'll also just briefly sponsor message from myself. I would love to talk to you about your challenges in the world of systems programming. If you're a person in the world of systems programming as a student or whatever, I'm looking to learn about people's challenges and how I can help them better with this. And so feel free to contact me and we can talk about any challenges you're going through with systems programming, technical, career-wise, or something else. Here's my contact info. Feel free to reach out to me on any of these methods. What's up, Lane? Nice to see you. First one in the chat. Appreciate you showing up, as always. What's up, Ray? No, you're not late. Just starting literally right now. Fresh off the stream, bites fresh off the network. Yep. How are you two doing? You guys having a nice weekend? I'm having a pretty good one. I was actually on a camping trip just the last couple days. Just getting back into the real world again. Okay. Yeah. Let me make sure my Discord ping goes out. Just drop that. Cool. Yeah. So, honestly, I'm super nervous I mean, both of these I'm kind of nervous to try to work on. The timer interrupt, just because it's going to involve probably some esoteric stuff with the APIC, something like that. And the test infra has been this long-standing sort of annoying topic that I've wanted to try to get to. Basically, the idea is that I want to have some integration tests where I can actually run the kernel with some test tasks and confirm that certain serial out messages still make it. So, yeah. Welcome to everyone in the chat. What's up? What's up, Cat Flare? Nice to see you. Haven't been camping in years. Got the kids back from swimming. We're doing a side project today. Server can be managed for a game I play. Nice. Cool. Side project Sunday. What's up? Pratamesh. Don't have much time today, no problem. Lane currently learning internals. What goes into an OS. Optimize my C++ code bases. Cool. Eventually make my own OS someday. How much assembly do we need? Not that much. I mean, for an OS, it's really only a couple key parts in my experience. Reading O step. What's up, vpool? Nice to see you. Appreciate everyone popping in today. So yeah, man, let's just take a look at things. So let's just open up the old code. This is what I'm talking about, where like this is so, it's let's see, it's annoying that I'm always just sort of like commenting out random stuff in my main to do some tests. And I am just wondering what I could do about this. It would be cool to have some kind of test suite where I can have just these all kind of laid out somewhere. Yeah, okay, I might reach for the AI also a little bit in this, but let's just think about this. So right now I just have the kernel and then the user space unit tests, or like the ones that run on my host. And I guess, yeah, what's as usual here, the way I go about thinking about this kind of thing is what's the simplest possible way I could do this? What would be like the smallest baby step? I'm just gonna eat the frog, bite the bullet, and just sort of try to go into this. So what's the goal? Have some integration tests, right? What does that mean? That means we run the real kernel in kernel mode and look for certain messages, text on the serial console. And then what would an example of that be? Real bad dad joke. Oh, dang, we got the dad jokes coming out. Depends on how much IKEA furniture you'll be building. Crazy. Yep. No apologies needed. Okay, I'm gonna briefly update the top text kernel. Okay. What's up, Cerebral? Can I run games? No, nope. Unfortunately, it's too small of an OS for that. Okay, let's just bite the bullet. What would it look like? So let's yeah. First off, what would a basic example of an integration test look like? What kind of test would I want to do? Can I install Roblox on iOS? Yeah, no, not these days. What you can do is you can write a function that creates a new task and exit. You can definitely do that. Print out your thread ID, your task ID. That's pretty much it. How much do you want me to pay you to make it run Roblox? Oh, wow. Tell me a bit more about this. Why do you want to run Roblox on my OS so badly? What's it to you? Okay. Okay, let's just take some screenshots of the current tasks on the system just to get a sense of what tasks are out there. Right. So these are these random tasks I have been using. The wait test and the noop task. And then most recently, last time, this is what we did. For the first time ever, a kernel task can sleep for 5 billion CPU cycles, which is what we were doing. So this is also an example. Yeah. It's only got the concept of a low-level task manager quite far off. Yeah, we are definitely not close to running Roblox. I gotta say we're pretty far from running Roblox. To be honest, yeah. What's up, Hello Code? Nice to see you. Okay, so yeah, and all this time, in order to test my kernel, literally, you can see me do this. I just comment out these random lines and add some back in, take some back out, and it's like really annoying. Also, I was doing all this guard page stuff, and I had this random helper that writes to a guard page. And so that, for example, is an example of an integration test. So there's this test that the flags are saved and restored correctly. And that's another test I did. And I think that is pretty much the bottom of this file. So we have color. So big test for yielding create task and exit. This is the test for task wait for exit. And this is the test for task sleep CPU cycles, and the test for guard pages. And this is the test that context switches preserve the flags. Yeah. What would you say, Lane is asking, what would you say has been the hardest or most difficult part in your OS dev journey? That's a good question. Hardest part, I think probably the hardest part was in the early stages in early 2024, where I was debugging a lot of really challenging kernel crashes when I was working on the JOS OS from MIT. And you can literally see it in the streams. I spent over like 4 weeks of streams debugging some of these strange kernel crashes in JOS. And that was, I mean, I don't remember when Claude Code came out, but that was like pre-agent world. I think I would otherwise probably used an agent to help me debug them. I think ChatGPT and AI was like kind of around, but only in chatbot form. So I think that is this the equivalent of Temple OS? I mean, I would not really say that, to be honest. It wasn't. Never did it really pop into my mind, thinking like, man, I need to wake up today and make the equivalent of Temple OS. So not in its current form. Okay, so here's my baby step. It's like, okay, well, what kinds of integration tests might we want to write? And here's five integration tests. And the idea is something along the lines of, we want to be able to have these tests be functions that run in some kind of test kernel, ? They run in QEMU and something, some way to get the serial output of QEMU, and then match against some string or regex, maybe, is the general flow of this. What's up, Rudy Ling? Got questions? Never seen your OS run. Can you showcase it? Yeah, for sure. It's not like, what even happens? It's not that exciting. Check it out. Bam. Okay. That's what the OS looks like. That's what the OS looks like. In particular, right now, the OS is programmed to run this test for the sleep function. So, so it like sleeps for 5 billion CPU cycles, then the task wakes up and it's a panic. So, because we're working on really the fundamental OS concepts. So, sorry to disappoint you if you were expecting some kind of like crazy GUI or something like that. Enrichment test, do you want to be able to have the tests to be functions for the kernel? Something like that. Can you write a program that fills up the memory? I mean, yeah, in theory, yes. I'm not going to do that right now, but you can, yeah, that's the whole idea, is like I can do whatever like weird stuff I want. So sys ready? Felt like you got me back into learning CS. You're only working on 6502 assembly. Nice, dude. That's awesome. I've never done that myself, but that sounds fun. All right, I'm gonna lock in like a little bit more. So here's the general flow. And so to be totally honest, I think I will actually lean a little bit harder on the AI to do this, because it's not really, let's figure out this git. So I have this commit, it's mostly these. What is this? I was yielding, and then I think this is a little bit unrelated. Oh, it's already time for the 20-second break, so feel free to join me for a quick 20-second stretch. Talking about assembly language. Java 2 is less painful. Yeah, definitely. A lot simpler. Commodore 64 is sick. 64. Yep. All right. Let me just, so we have this one random thing. I don't totally remember what it does. Let's commit this. Random. Wait, test change. Need to clean that up later. Then we have this hunk, which adds the test pair for sleeping. Test tasks for task sleep CPU cycles. All right, and then we just have this kind of remove comment, do noisy, or comment out noisy logs. And then we just have this, whip run the sleep CPU cycles tests. Okay. Whip. Okay, cool. So now I'm gonna make a new branch. I'm gonna call this tests. And let's just take the opportunity to practice a little bit of agentic development. And I normally don't use a lot of AI, but I think it's also important to recognize what is most important to work on versus other kind of side things. And in this case, like integration test framework is something I want to have. It's not my passion, and it's sort of just a blocker that's in the way of the timer interrupt and other more exciting stuff. So let's just give this a little bit of a try. So first of all, let's start in planning mode. And low key, can I use Fable? Maybe we'll use Fable. So I'm gonna let's start trying to prompt a little bit what we want. These functions be test run some kind of. So what's the simplest? Again, I'm still gonna design the architecture of this test infrastructure. What I'm thinking, so currently the way it works is we have the actual kernel, which is really like the kernel binary, which gets packaged into the kernel image, and that thing like boots in QEMU and stuff. We also have kernel lib, specifically kernel lib test. And so this is, let's say, like actual kernel boots in ring 0 on QEMU. We have kernel lib test, which is kernel unit tests, generic code built as a binary that runs on my Mac OS system. Kernel lib test. And what we would be doing is sort of adding a third thing to this whole universe. And it's, I don't really know the name, but it's going to be something like kernel integration test or something weird like this. And the kernel integration test is going to be quite similar to the actual kernel, but I think it's going to be a little bit, it's obviously going to be kind of different. The job of the kernel integration test is not to run a kernel, it's to run some specific functions, basically. So it's going to be conceptually closer to the actual kernel, and this is sort of a separate type of thing. And this is going to be kernel integration tests. Boots in ring 0, but only runs some specific tasks, test tasks. And we have some design work to think a little bit about how we want to do this. So, for example, I'm just going to brainstorm a little bit. Like idea number one is that takes a command line, like every task gets a command line, or like gets a title. There is a command line argument to select which task to run. So we have kernel command line arguments, and so we can do something like we can pass something like test, and then, for example, like guard page test or something like that, and then that will configure this kernel integration test to only run the functions for the guard page test. Another option, well, maybe just to flesh out the design a bit more. So it's sort of like maybe even to code it out. I don't know. I'll just keep fleshing those. So the idea is we have this kernel image. All the tests are there, but when you run the kernel integration test kernel, you pass in a command line argument, and it only runs one test. And this, and then this runs the test and prints some output to serial out. And then there needs to be some kind of external component that like greps the serial out for a certain expected string. So there's going to be a couple pieces to this. So every test is going to have a couple pieces. Every test has the kernel functions to run, and then some external script integration that will grep the output or something. And there will probably be some script that sort of orchestrates a lot of this stuff. So that's sort of the idea. The other design approach is a lot more heavyweight, where it's sort of like we just run. I don't even know how it works. I think it's a half-baked idea. We would just run, like in the same way that I can run my unit tests, like, which I just did right now. Like I just run my unit tests, and they just all run, and then they like all pass. We could imagine a like similar thing for this kernel integration test, where just the kernel has all of the logic to run all of the tests and check that they worked somehow, and then just say like tests passed. But honestly, I think that's kind of a half-baked idea. It is totally unclear how I would do stuff like testing the guard page thing with that approach. I'll just call this weird half-baked idea kind of implement full unit full test framework in kernel mode. And the idea is like you run all tests by simply booting and running the kernel. I'll also sort of, just to be thorough, another point of the design space is we actually put the tests directly into the kernel binary. No kernel integration test separate kernel. And yeah, this is sort of an interesting idea, and it's just sort of like there's only one, so this thing goes away, like there's only one kernel, but like the tests are all like kind of baked into the kernel, and they only get activated if you pass certain flags, which will trigger the test to run as opposed to the normal flow of the kernel. And actually that is kind of an appealing approach, and I'll explain why. So and if you pass certain flags, then the tests, or specifically a test runs instead of the full kernel. So something like this. Yeah. So these two ideas are quite similar. They're basically this, 2 and 3 are basically the same thing. The question is just whether we actually go as far as having a separate kernel integration test kernel and then as opposed to like the main kernel, or if we just push everything into the single one. And really just the main difference and the caveat here is that I was confused. Actually, idea 1 and 3 are basically the same thing. Maybe I'll rename this to make it so. Idea 1 and 2 are basically the same thing. Just the downside. Okay. Separate kernel integration test kernel binary. Just the downside is that there's more complexity, more build system, another build target, etc., etc. The advantage of this approach is that keeps test stuff out of the main production kernel, which, you know, maybe you care about, maybe you don't. It decreases the, which has a number of knock-on effects, you know, if we like, which decreases the size of the production kernel. Yeah, and basically, the pros and the cons are just opposites, as usually happens. So it's like for this option, less complexity in the build system, etc. And the con of this approach is that the kernel binary gets bigger because it's shipping all tests in quote unquote production. And so now we have a choice to make. Which one do we like better based off of our, I guess our values or principles? And for me, I actually don't really care about I mean, it's a quote unquote production. I'm not shipping this in production, but I don't really care about having the kernel being bigger with tests. I do care about complexity of my setup. And I'll be willing to trade kernel size if I were to get less complexity in the build system. So that's actually sort of leaning us towards this approach in the design space for how we might do this. So just kind of showing you a little bit about how I think about problems and think about designing a solution before I even implement it. And so we're converging on sort of like, this is not really there. This is just sort of like kernel plus integration tests all in one thing. And I think it's worth at least exploring this option. I think it will work pretty well. So yeah, that's a little bit of a step forward, but we still have a bunch of questions we need to answer. What's the question color? Okay, so mostly what does the orchestration scripts grepping part look like? Yeah. What's up, Abno Benzine? Nice to see you. You are on time. You're very much on time. Or I mean, you're not completely on time, but you're not joining like 1 minute before the stream ends today. So that's awesome. And the question, what does the orchestration scripts grepping part look like? So maybe we can even begin to prototype a little bit about what this looks like. This will be, I mean, yeah, limine.conf. This will also be interesting. This will pretty much be our first time making use of kernel command line arguments. Yeah, I mean, there's one. one problem I'm just thinking about is like, how do we actually... let's say we wanted to, yeah, just like run the kernel and run a certain test. The idea is that we're going to pass a command line, like it's going to be a string, I guess. So it's going to be something like this. So it's going to be like test guard page, something like this. Rudy asks, I can't remember if I've asked, is it Unix-like or does it adhere to POSIX standards? No, probably no for both of these. I'm not really planning on implementing POSIX at all. Whether it's Unix-like is an interesting question. I would say it's probably going to be somewhat Unix-like, given that I'm mostly familiar with Unix. But I think the most important sort of thing to step back is like I'm not really planning to make a desktop OS actually. Like the OS that I'm working on seems to be a bit more in the style of a real-time OS or like a small embedded OS. And so I think we're going to have some differences there. So yeah, but I'm much more interested in just doing things as cleanly as I can think of how to do them, and I'm not really concerned with compatibility in any way for the moment. So yeah. And give me 1 second. It just started to rain kind of hard. I'm just gonna check my windows to make sure they're closed. Right, windows are closed. Rain is outside my house. What type of integration test are you doing? So the idea is to have infrastructure for doing integration tests at all. And the examples would be like, it would be cool to have a test. Oh, is it already another time for a 20-second break? All right, be right back. Feel free to join me. Yeah, so for a really simple example is, it would be cool to have some kind of test, like where I can test that writing to a guard page triggers a page fault. For example, that was something I just tested manually by like hacking the main function of the kernel basically. But yeah, so that's just an example. So Emilio, any unconventional choices when designing the kernel? Yeah, I'm not using dynamic memory allocation. I'm using C++ with a lot of third-party libraries. I would consider both of those somewhat unconventional choices. Yeah. And I'm trying to do some testing, which I think is also unconventional for hobby kernels. So, yeah. So, Yeah, the idea is like we would do something like this. It's like we would very, very rough no, K-main. It's like, what would we even do? We would, all this stuff is there. I need to remember how this arg parsing stuff works. So we would have, wait, how do you do a string actually? Store. Okay, how does this work again? As string view. Okay, let me just take a screenshot of this. So we would take a string that's something like, it's going to be test as string view, and we're going to store it into string view test string. Looks good. And we're going to call it test name, or maybe test ID or something like this. Emilio saying, well, C++ isn't exactly unusual, but it's definitely super interesting. Curious to see on this. So you got yourself another discoverer. Awesome, welcome. And thank you very much. Yeah, I mean, it's not so unusual, but in my experience in the hobby OS dev scene, I've seen, yeah, it's relatively unusual compared to C and Rust. So that's just why I call it a little bit unusual. View. So args test ID. And so we're going to have this command line argument and basically at some point we're actually, how do you see if you got one or not? That is sort of a question. I guess it'll be empty. At some point, something along the lines of if, wait, how do you do this? You pass the, it's this array of args. Oh, so it's just, what did the AI say? If C equals guard page, otherwise, yeah, something along the lines of this, args.test id.empty. Oh, what the? Is there no string view? Okay. What can you do with this string view? What's the default state of a string view? Null pointer. length 0. So I guess we would check. Yeah, we would just check the pointer, so like the data. So so it's like if we have a test string, have a test do that instead. Something like then otherwise run the kernel. Something along those lines. What is the current size of your OS in megabytes? Also, what's up, Wall Marcus? Good to see you. Let's take a quick look. Kernel elf. 693 kilobytes, almost a megabyte. I mean, not quite, but which is shockingly big for how much code I have. And I did some investigation into this. The reason it's so big is because, for one thing, I'm doing a debug build, which has a lot of debug info. And then second reason being, I'm using this library called Frig for string form for my logging, basically, which allows me to do nice things like using these braces and stuff for my logging. And that library is not very optimized for binary size and uses a lot and uses templates quite extensively, which bloats my binary. So that's why. Yeah. You drink beer while doing office work? This is not a beer. It's not a beer. It's not a beer. To be clear, this is a soft drink. To be very clear, I'm not drinking on the stream right now. But look up the Balmer Peak if you haven't heard of the Balmer Peak. Oh, we can take a quick peek. Balmer Peak is a concept from, it's just a programmer achieves quasi-magical coding abilities within a very specific blood alcohol content range, peaking at elite. Yeah, so in case y'all have never heard of the Balmer Peak, this is the Balmer Peak. Discovered by Microsoft in the late 80s. Back between 0.129 and 138 confers superhuman programming ability. You can't give a team a year's supply of whiskey until they get cracking. Has that ever happened? Windows ME. Okay, so like, you know, something approximately like this. And so right now with my current configuration, my Lemony is configured to pass this this command line. So we should actually hit that panic if I run the kernel. We should just see that. So yeah, we can see that with my current config. I'm passing in this flag, and that's causing us to go into this thing. And if I were to omit this and rebuild the kernel image and run it, we're gonna hit the actual kernel main, which is currently running this like random test that sleeps. So that's obviously like super basic, but it's the broad idea of what I'm trying to do, where it's just like, we just have this separate branch very early on that checks if we're supposed to go and do some test stuff. And if that's the case, we go and do that, and we don't do the normal kernel. Alcohol and weed. What's up, Jared? Hates games. Alcohol and weed are for brainstorming. Nicotine and caffeine are for actually building the thing. Yeah, feel free to weigh in on this discussion of drugs and programming if you have any opinions on that. And yeah, that gets to this problem I was pointing to, where it's like, how, like, it's not really easy to just pass, like run the kernel and pass in a certain arg, because it requires, like, this config is sort of, it's like baked into the kernel image. So yeah. What's up, Mabda? What inspired you to start this project? I just really wanted to learn about OSs at a deeper level. And I also got inspired because I wanted to see what it would look like to use C++ for this. So yeah, I've just been interested in hobby OSs for a long time. How much time a day you run your OS to see how it's going inside VM? I mean, I don't run my OS, to be straight up. Like, I work on it during these precious 2 hours per week, and that's it. What job do you do? I work in the music tech industry. NSG, what's up, NSG? Joining now, integration testing, IC. Yeah, and you're actually the perfect person I want to talk to about this, because I think I want to brainstorm a little bit. Yeah, I'm not sure, NSG, if you have done integration testing for your OSs before, but my idea was to have some way to run the kernel, but then only have a specific like kernel task set to run, and it'll just do some like operation, and then there'll be some text to the serial out, and then I can have some like wrapper script that like greps to make sure this particular text appeared, which I can use for things like testing that my guard page is not writable, testing that testing that the flags are preserved when context switching, because that was an actual real bug that I had. Stuff like this, because currently I'm just doing this weird thing where I hack my kernel's like main function just to like run different tests. So that's the idea. And so my design so far is just to have all the tests be compiled into the kernel. And so the kernel is still only just a single kernel, like binary and image, I guess, but based off of the command line argument. You can tell the kernel to not do like the normal boot process or whatever, but it just goes and directly executes just a single test. And the problem is that it's sort of like, it's not actually that easy to just like pass a command line argument. Like if I just have the kernel image and just want to really quickly from like my dev machine, just like run a specific, like pass a specific argument, it doesn't feel super easy because it seems like I would need to like select something in the boot menu or something like this. So I haven't looked at the boot screen in a while. Dang, what is going on? Wait, what? I tried to make target, make QEMU. Why? Wait, I'm just trying to see the Limini boot menu. What? Why am I not seeing that? Is it because of? Wait, shit. Booted the kernel. Wait, what? I used to be able to get Limini in, oh, what am I doing? I'm trying to, yes, I don't have like a lot of options here. Yeah, so right, I only have one option. I'm just trying to think about how this would even work. So let's say I want to have two integration tests. Like I'm going to have, like let's say we're going to have the main, like kernel. I don't know, we'll call this like kernel production or like something weird like that. Then we'll call this like test guard page, for example. I'm still sketching this out, and so in this case we're like passing our normal production strings or whatever. In this case we're going to pass the guard page command line. But, well, first of all, I have this weird thing where I can't actually see it in the, but it's like, okay, so now it's like I can select between the two. I can be like, okay, let's run the production kernel, and we get this whole thing in the serial console. But then I can be like, okay, let me run my tests, but I need to go over here and like select it in the GUI, which is not really like scriptable. So you can have sub entries by doing / yo. Okay, that's cool. So that's awesome. Also, what's up, Ismail? Nice to see you. So we got the kernel, and then we're gonna go with a production. Wait, no, that's the wrong place. We're gonna go with production, and we're gonna go with test. Dang. Okay, time for another palm tree break. Feel free to join me. So did I get that right? So let me just try this thing. You know, I think, whoa. Is that a club mate? Absolutely, it's a club mate. Wow. Dang, that's a crazy feature. So can I go back and collapse? So now I can run boot protocol not specified for this entry. Dang. So do I need to... Wait, so do I not put this here then? I mean, frankly, this is all a little bit of a distraction, but this is interesting. Need a race over here. Production. Executable path not specified. Wait. Are there docs on this? Conf. Low key, are there docs? What can I? No. Wait, I'm confused. I thought the point of a sub entry, let me limini conf docs. I thought the point of the sub entry would be so you can reuse sub, or where is the con? What do I even search for? Slash. Okay. Call the sub entry. Oh wait, is it purely for the GUI? Is it purely just to show like this navigatable like tree in the GUI? Oh. Okay, I see. In that case, I'm a little bit less excited. I thought it would be a way to sort of like I could say like I could have some core configs in my top level one, and then in these ones I can only have this like one line about what's different about these. So I guess it does not work that way, so that's sort of unfortunate. So I will roll back what I was doing. Anyway. But yeah, so basically, I mean, I still have this weird issue where I'm not able to actually see I think it's because I'm using the debug con or something like that. Monitor. Does this help the situation? I'm just trying to see the serial console in my terminal. This was like, I have the serial set to yes. Try serial stood IO. Oh wait, wait, what? Man, I'm confused. What's okay? Stood IO. Sorry. Okay, I totally forget how these flags work, to be honest. So you can't monitor, like, oh wait, is it this? Is this how I need to do it? There we go. Okay, cool. That's what I was expecting. So, yeah, this is not like that important. It's just a quality of life thing. Like, so we don't need to flip through and find like the weird GUI window. But I still, none of this solves the real problem. So it's like, on a conceptual level, I want to be able to write a script that's like run OS test guard page or something like this. Like that's not gonna work, obviously, but it's like, you know, or like test wait test. Like I want to be able to like run a command line on my machine and trigger a QEMU run of this like one test. And but the problem, like in order to do that, it seems like, oh, oops. Dang. Wow. Dude, I can't even kill this QEMU. Okay. I guess it's called QEMU system, something. But so like what I want to do is like conceptually be able to run stuff like this, and just have it like run QEMU, print out a bunch of stuff, and then like exit, and then I can grep that output for some certain text. But the problem is, in order to like select a test, currently I need to go into this GUI thing and like press up or down. And so I guess my question, is there a way to non-interactively select something here? Because if there was, then that would at least help me a little bit. I think maybe another way to put it is like, I just want to have some, like, is there some way I can pass some data via a QEMU command line argument and have that data be visible to a guest? I think maybe here's the part where I'm gonna start reaching for the AI to help. Okay. So I'm working on integration tests for my kernel. The idea is to start very basic. I'm just going to pass a kernel flag or command line flag to the kernel. And if there's something like test with a test ID, it's going to branch on that and run not the normal kernel boot process, but just a different boot path that will only execute the kernel functions for this test, and then exit, with the idea being that I can then grep for some serial console output via some driver script and confirm that the kernel is working on an integration test level. But my challenge is how do I actually pass arguments to the kernel? So I'm using Limini bootloader, and I can have some boot configs with different flags, but at boot time I need to select one of these, and it seems to require an interactive process. So I'm wondering if there's any way I can do this non-interactively so I can script it. And to be very specific, I'm wondering if there's any mechanism that QEMU offers where I can pass some kind of data in a flag or something, and that data will be visible to a guest OS. Okay. So I'm just sort of talking to the AI a little bit, like file funny or pipe. Okay, NSG with the detailed QEMU knowledge. Yeah, I also thought Fable 5 was banned, so. Quick question, does anyone know, I mean, I've heard that Fable uses your tokens much faster than Opus, so I'm kind of wondering if I should actually be using it for this task, or maybe if it would be better to save my tokens for something else. I think Opus has been pretty good in my experience, so. Just doing some reading. My kernel. I'll just quickly say ignore anything Meson related. That was just an experiment. The kernel uses CMake, C devtools.cmake, and also Limni for the bootloader. Personally, don't use Claude. No idea. Got you. Yeah. But yeah, if there would be some way to be able to sort of like pass like some like user data test equals guard page, and then somehow just like have these bytes be available somewhere in memory for me to read, that that would sort of solve this problem. I hope I'm being clear about what I need. Like conceptually, this is what I want to do, and then be able to be like, okay, grep page fault, right, and then test passed, something like this, right? And then I want to pass an argument. The kernel's going to do something kind of like branch on that and then see what it needs to do. I don't really remember what device it was, but it's possible. Okay, that's encouraging. Maybe while this thing is, wow, this thing is reading the internet right now. Oh, config.md, that would be the place. Config. No, wait, what? Oh. Is there a config.md? Oh, I'm in the wrong repo, maybe. Okay, okay. I have no idea what it's reading then. Okay, in parallel, maybe I'll get, okay, in parallel, give me 1 second. I'm going to get a ChatGPT window going, and we'll like AI max. So oh wait, continue, sorry. Be worth it to just make run OS test, whatever test, where run OS test is developed along with run OS, or else just have a separate bootloader config for production and main kernel. I'm not sure I totally understand the question, but it's not really the problem of like having one config or two configs. It's more the problem that like I don't have a way to like dynamically just easily pass a command line argument like when I type out like my Mac command to run the QEMU thing, and then have the kernel be able to sort of like see that and then react to it. And like the bootloader config is not a great mechanism because it's like all like hard coded, and then I need to interactively like use the GUI of Limini to like press up or down to select it. Okay. Okay, we got 2 answers from both AIs. Goal, scriptable integration test, boot the kernel with test ID. Run only that tests boot path, emit a marker. I think also have a script grip for it. The blocker. Okay, so it understands what I want to do. Direct answer to the question. Yeah, okay. Before I even read it, we're definitely screenshotting this for later. Okay. Yes, QEMU has exactly this mechanism. Firmware config FW. Name of anything exposes a named blob to the guest through a tiny I/O port. No bootloader involvement, no ISO rebuild, fully scriptable. Limini 9.x has no support itself, and its default would require regenerating the ISO per test. Oh, wait. Reading for config directly in the kernel avoids all of that. So first of all, that's sick. That's freaking awesome. I think we might be able to use that. So current state, this is just a summary of what I have. Parses command line with this thing. Conf, I have some IO helpers, so it knows the OS. The test ID flows driver script, passes for config with name, something like this. Some driver reads the blob. Oh, parsed with the existing. Oh, this is interesting. We could actually get this string and then parse it with the existing frig arg parsing code, and maybe. Okay, so this actually sounds plausible. And to be very specific, this is exactly the mechanism that I think NSG was sort of like implying, or like had seen before, which is very, very cool. So with this flag, this is just like a piece of QEMU knowledge, but using this flag, you can pass data to a guest OS in like a dynamic way, where you can just put whatever you want into a command line arg, and then QEMU will dynamically make it available in a place that the guest can read. So before we possibly do that, let's go take a look at what ChatGPT said. ChatGPT generate a 1 entry limit. Okay, so ChatGPT was saying, let's do a different approach. It's saying, generate a 1-line Limini config, which is also an interesting way to solve the problem. So instead of, I guess there's a couple different classes of solutions for this. Let me just recap things. Problem. We want to do run OS test guard page, for example, or test like task wait or something like this. It's like grep page fault or grep test passed. But how can we dynamically give that test ID string to the kernel? We have kernel CLI flags, but they are all baked into the liminy.conf. Okay, feel free to join me for a stretch for 20 seconds. But they are all baked into the liminy.conf. We then need to interactively select it from the liminy GUI as it boots. So the problem is we don't have a non-interactive way to boot a particular test ID. Solutions. Okay, so solution number one. I'll start with the one that we're probably not going to use, but solution number one, the simplest thing, in the absence of this fancy QEMU feature that actually allows us to pass data to a guest, we generate a liminy.conf plus a kernel image, like in real time as the tests run. And so basically we would have some code that dynamically generates a liminy.conf with, like, if we wanted to, in order to implement this behavior, what this run OS script would need to do is it would need to dynamically generate a liminy.conf and it would need to pass this string into right here in the generated conf. And then it would dynamically generate a kernel image by running the whatever command it is. It's like this XOR ISO command. So we don't need to recompile the kernel. We need to repackage it into a new image with this dynamically generated liminy.conf. And then we would be able to just run that. And I think since we could set it so that there's no timeout and there's only one kernel, and so it's just going to run this. And then, yeah, do this for every test. So that's one way to do it. Dynamically generate a kernel image in real time for every test. We'll call it a minimal liminy.conf that only has a conf for running the test for every test. Downside is that slow. It's like slow to run So RISO for every single integration test we want to run. Actually, RISO is not super slow, but I think it takes like a second or half a second or something. So that's kind of a downside. But the advantage is that this approach does not require any fancy QEMU features, does not require any custom driver in the kernel. That's kind of an advantage. The other way, which is what it seems like we're going to do, is find a way to dynamically pass data from a QEMU command line directly into the guest. And with that mechanism, we don't need to do this dynamic conf and image generation thing. We just take this string guard page or whatever and just literally pass it into the QEMU command line, this right here. And so it's like dynamic at sort of a different level. So QEMU has this apparent. Well, maybe like let's do a quick double check because the AI could be hallucinating or whatever. But in my experience, the AIs have been hallucinating less lately, which is cool. So it seems like this thing is real. This hardware interface allows the guest to retrieve data items that can influence how the firmware configures itself, or may contain tables to be installed for the guest. So, okay, this is interesting, and yeah. So yeah, so I think it's suffice to say that this is real, and so QEMU has this config, and so what we would in this way, we simply pass the test ID as a QEMU command line. The kernel side reads from the firmware config device, question mark, gets the test ID string, dispatches to like test code instead of kernel main. And there are some question marks that I don't really understand how this works. There also needs to be a way for the kernel, like under normal boot, the kernel needs a way to detect that there's nothing being passed here. I think we'll probably want both actually. So want both ways to pass test. The way one is going to be kernel command line arg. The way number two is going to be the firmware config. Because it still would be kind of nice to be able to pass a kernel command line arg via like the bootloader config. It's just that's not a great solution for like running these unit tests in general, but it's sort of a nice functionality to provide. But really in practice, this is more of the mechanism that we would be using. So we need to explore that a little bit more. Let's check out the chat. Jared hates games. Seems like option 2 is what you are wanting, or option 1 is the easy workaround. Yeah, I would agree. Yeah, I mean, it's nice to know. I think that option 1 would actually work. And I mean, it does have this advantage of not needing like this driver or like quote unquote driver for this like firmware config interface. But this part is kind of weird. I mean, I would say another I don't know if it's a pro or a con. I mean, a pro is that the kernel code is simpler. But the kernel is just simpler. All it just reads from the kernel CLI args, period. No, like, from a kernel point of view, the kernel is just really simple. The kernel command line args are just the one source of truth about how the kernel behaves. And that's actually kind of nice at the expense of the slow, and maybe it's kind of weird to regenerate all of these liminy comps. Or maybe it's not that weird. I don't know. I think I haven't completely ruled out option 1, to be honest. I think, yeah, I mean, let's just finish the analysis. But just to check the chat. So Ismail, will the string you pass as a parameter to run need to be processed before appending it to command line? So I'm thinking ideally not really. I'm basically I'm thinking it's sort of directly passing it. Like if we were just to pretend this file is called like run os.sh or whatever. Actually, I've no idea how to code bash, but I know you get it's like question mark 1 and 2 or whatever. No, $1 1 and 2. Man, it's been so long. It's just like QEMU system x86-64, all our args, and then like firmware config, blah 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 blah. But it just like directly passes whatever. I mean, we can decide how we want to do it. I think, and realistically, this run OS script is going to be called like run OS, or like run kernel integration test, basically. That's specifically, and it could look as simple as this. It could be as simple as guard page, in which case it's just like something like that. You know, we could have like a -h, so it's like if -h show the help message or whatever, exit, something like this. But otherwise, we just run the QEMU command. So, which would then like, and then we can sort of like, I mean, this is so embarrassing. I don't really know like how to write bash, but it's just like output equals, we just get the output of this command, and then it's just like if yeah, I don't know what basically like something stupid like that, where we can then analyze the output and like grep for a certain string, or like grep for tests passed, or grep for page fault, or whatever. And then we can just have this, then we can have just some like, we can like run these in a loop. We can have some like big like something like all the tests. I'm gonna write in Python because I just don't know the bash syntax, but it's like wait task, and then it's like for each test, like something like this, you know, in like really weird pseudocode. Check output for text or whatever. And then we can just have this one script that just like runs all the integration tests. What if you have like multiple parameters? Is that a thing? Yeah, good question. I mean, yeah, like for this kind of thing, we have full control over however we want to do it. And that's just a design question. And the way I've been designing it so far is that it's only possible to like run one integration test at a time for like one invocation of the kernel. Because like you could imagine like, okay, what if we want to do like two? Like, wait, like run two. But the problem is that like these integration tests, like the kernel, it might actually crash the kernel. For example, the guard page test, the idea behind the guard page test is the kernel actually tries to write to the unwritable guard page and like page faults itself, which ends the kernel. And so if our design only allows running one test like per run, then it's like fine to do that, to like crash the kernel in like an integration test. But if we wanted to allow the ability to run multiple tests in one invocation of this, we would need to find some way to like have the kernel recover from the page fault, completely reset its state, and then run this next task. And that's like super complicated and hard to do. And so it's a simpler design if we just say, no, like you can only pass in one of these things. And if you want to run multiple tests, you need to do that at a higher level and like have like an orchestration script that like goes in a loop and like passes them one at a time. So that is how I'm currently thinking about that. It's a wrapper script. It doesn't even reboot QEMU. Like the idea with this script is that we're gonna make it such that the kernel at the end of running the test, it's going to like shut down the VM. And there's like some kernel, there's like some or maybe are you suggesting, let me see on the next task. Basically the way I'm thinking about it is that each test is going to end like with the kernel shutting down the VM. Although, I mean, it's interesting, if the kernel hangs, then it might not necessarily shut down. Like it's not going to hit that code that like shuts down QEMU from the inside. And so I think we'll also need to have a timeout in case the kernel does some like really weird thing, hangs in a loop forever. We'll have like a 5-second timeout that kills the QEMU process after 5 seconds and fails the test. I think I'm gonna write some of this stuff down. Other considerations. Well, maybe, yeah, so halting the VM. What if it hangs in a weird way? Need some timeout mechanism that kills the QEMU process. Yeah. Handle test iteration on the host level for testing. Yeah, that's what I'm thinking. Yeah. So we'll just do it on the host level, and there'll be some like loop in this script that just like does that with like some like run with timeout or something like this, something like that. I might script this in Python actually. I don't know, because I just like, I don't write bash enough to really like know the syntax or whatever. So, but yeah, to flesh out more of the design. So it's like, okay, call it more design notes. Run one test ID at a time per kernel test invocation, allows a integration test to crash and test some of these cases, e.g. writing to a guard page. Like pro simple, no need, right to a guard page, and like any, or like running multiple tests is implemented at a higher layer by some orchestration script. Pro simple, no need to weirdly recover from a crash, reset kernel state, run a new test, something like that. More design notes. This is another design note. Yeah. Okay. Rule is if more than 10 lines, write it in Python. Good rule for sure. Yeah, all right, posture check. Anyway, we didn't really finish this analysis. And so we have these two main options. This one where we sort of are generating new kernel images. So like kind of like dynamically that are configured to run the test at like the bootloader config level. This other option where we only have a single built image, but the image itself is dynamic and reads from this special interface. I think either way, it'll be fun to prototype the second one. Whether or not I actually go with it, it'll be fun to try to learn to use this interface. But just to finish the analysis, so as usual, the pros and cons sort of like are the opposite, but the pro is it's quote unquote faster, in quotes, because it's not actually clear how slow this really is, to be honest. I mean, writing, like stamping out a limine conf is not slow, and then running xoriso, it's not recompiling the kernel, it's just packaging up a couple files on disk into a disk image. So that's in principle, that's also not really like that slow necessarily, but this is faster. No need to dynamically generate files for every test run. Yeah, so the pros are it's faster. I'll call it simpler on the script, on the script orchestration. I'll call it slightly simpler on the script orchestration side. It's a benefit. Con is, yeah, it's like requires fancy QEMU feature, requires a driver, a firmware config driver in the kernel. But by far, for me, the biggest downside of option 2 is this one, this like conceptual kernel simplicity thing, because just to like draw it out, if we imagine the kernel, here's like the kernel, and here's like some command line args, we can sort of visualize it as like, what is the input that the kernel is interpreting in order to decide what to do. And currently it's just like super simple. It's like what's like the command line and other limine data that's passed, but all right, quick 20 seconds, be right back. Realistically, pretty much the kernel command line is like the main like input data that influences the behavior of the kernel. This is nice and simple. And what option 2 is proposing is to make this a bit more complicated. So now the kernel is reading 2 sources of input to decide what it needs to do. Which is just like a bit more complex. And this is just super simple and super clean. This is a bit fancier, a bit more complex, but it's just a matter of pushing around the complexity. On this way, we push the complexity into the orchestration scripts. Here, we push the complexity into the kernel itself. And that's simply the trade-off that we need to think about. And in general, I'm trying to reduce complexity in the kernel itself. Like the kernel is already such a complex thing. If it's possible, I do think it's actually good to reduce complexity in the kernel. But this is just such a cool feature though. So I want to play with it and try it out. But if I were to really do this in production, I would not rule out number 1 necessarily, because it seems like it actually like kind of could work. But either way, let's prototype both of them. We can probably use AI to prototype them very quickly and just see, but I'll just finish the analysis. So kernel complexity. There is now no longer only one source of dynamic input, CLI args, but now there's 2, the CLI args and the firmware config data. I'll just summarize it like this. More complexity, dynamism, dynamism in the test scripts, more complexity in the kernel, to summarize the 2 options. So I'm just noticing that we're coming close to the end of time, but maybe we could vibe code both of these. Let's see. So I actually want to try vibe coding the first one. This one is just kind of stupid and simple. I think we could, oh wow, I just locked the sticky. I think we could vibe code it pretty quickly. So I'm going to talk to Claude a little bit more, but first I want to actually fully read through this thing. And so ChatGPT was going for option number 1, generate a limiting config. Your test runner file creates it dynamically. Rebuild the image with XOR ISO and run it like so. And then it's exactly, I would structure the command line as ordinary key rather than making the command line the test ID. Okay. Why QEMU append probably does not solve this. Whoa. QEMU has a familiar option such as append. That is also interesting. This seems to be kind of a different option for number 2, actually. So, yeah, this seems to be a alternative way to pass data dynamically from like the QEMU command line into the kernel, but in a different way. Rather than having some strange device, it actually does it through the CLI args. Really interesting to see how you break down these problems and weigh the pros and cons. Thank you. Yeah, I think this is actually super important to really internalize. I think, yeah, one of my key points of how I work and how I think it's important to work is just realizing that everything has trade-offs. Everything is pros and cons. It's always a matter like of weighing things against each other. And like in doing that process, you understand the problem way better, and it takes time. I mean, it's taken this like whole stream to sort of weigh the pros and cons. But after doing this, we have really mastered the domain of the problem, and we have really strong reasoning behind what we're choosing. But it is slower, and so that in itself is a trade-off. You don't always want to be doing like this heavyweight analysis, but I think people often skip this. Like even at the start of this, I was very strongly just considering jumping straight to option 2. Like that seemed like the perfect thing. I mean, even ignoring this like weird thing which we are just learning about, this append thing, I was very much inclined to just simply do option 2. But then I thought about option 1 a little bit more and realized that it's actually probably not that slow, and it's not even that weird. Like, this is just how the script would look. It's not that weird, and actually has one particular upside that I really value. And so you just really understand what you're doing a lot better if you think about things, you understand it better. Is my point, I suppose. So yeah. So let's finish seeing. So this thing is like, there's this other append thing. What is the stream schedule? Every Sunday morning US. Yes, exactly. Yep, I do Sunday mornings, 10 a.m. Eastern time, US. To be clear, I live in Europe, but I just speak in terms of Eastern time because I think people just sort of, I personally just orient towards Eastern time, but because it's also where I'm from. But yeah, Sunday mornings. Unless, I mean, it changes sometimes, and I post in the Discord when it does, but it's every Sunday morning. Okay, but append belongs to what? So what? Oh, append belongs to QEMU's direct kernel boot path. Okay, I didn't really understand what that means at first, but and that's important to know. So QEMU offers at least two boot paths that I know. There's like number 1 is like the full system image boot path, which is what I'm doing right now. I'm taking my kernel elf binary, I'm packaging it up into a system image with a limine config, and I'm in my case, I'm putting it onto like this like CD-ROM. Like I'm using XOR ISO to make a CD-ROM ISO, and then I pass that ISO image to the -CD-ROM argument of QEMU. And I only do this because that's what apparently you do, like when you use XOR ISO to create something, it creates an OS, an ISO file, and apparently just pass that in the CD-ROM argument. What this is saying is that there's a different way to boot a kernel with QEMU called the direct kernel boot path. In the direct kernel boot path, you don't construct an image. I believe you just simply pass the kernel like binary without all of that packaging stuff. Without all of that like XOR ISO, without all the ISO, without like even the liminy conf, you don't pass that. You literally just pass the kernel image. And this is designed, I believe, for Linux kernels specifically. And in this situation, it offers a way to pass additional kernel command lines, which I believe are specifically like Linux kernel command lines using the Linux. I think it also supports multi-boot potentially, but I understand that it's mostly Linux based. Anyway, yeah. So the takeaway is that this actually doesn't work for us. This is a specific mechanism that only works for like the Linux kernel or a kernel that implements the Linux boot protocol. And since I'm using the liminy boot protocol, I'm not using the Linux kernel boot protocol. And so therefore, this is not an option for me. But it does say that QEMU has this firmware config thing. Yeah, but then it's saying this has a cost. Your kernel must implement a firmware config reader. It is not automatically presented. It is QEMU specific, right? And so these are exactly the downsides I wrote in red over here, right? To be clear, it has a cost. QEMU specific feature, kernel complexity, you need to have the kernel driver, right? So it's not like a magical dream solution necessarily. And then it's going even further to say this is probably the wrong abstraction, which is entirely the reasoning around option 1. It's an argument for option 1. It's like option 1 is actually the right layer of abstraction to be implementing this solution at. Then it's saying this makes more sense if you eventually want to inject like a lot of other stuff that's awkward for a command line. So it's also being pretty thorough. You could also automate the keyboard selection, which is crazy. That's freaking wild. So we could try to automate it by like pressing down and selecting stuff, but that's genuinely the most cursed and worst way to solve this. And so ChatGPT is advocating for option 1, Claude proposed option 2, and ChatGPT actually argued why it doesn't think option 2 is good. So let me check the chat. Any tips to beginner in C++? I would say, write your own version of standard library classes. But that might even be a bit more advanced if you're a real beginner. I think if you're a real beginner, I think just write some C++ code, like find any tutorial, and just start doing some stuff. Like, I'm sorry I don't have the most amazing advice for that, but I mean, CPP contalks are pretty good and stuff too, but I would just say just just start writing code. um, and don't overthink it too much. Or the question should be, how fast can I make easy testing capabilities so I can get back to doing the actual project? Move fast, break. Yeah, I think that's a good point. It's like, well, I think that's part of it. I think that's definitely a big part of it. It's like, I don't want to be spending like a month writing infrastructure, like integration testing infrastructure. Ideally, I want to like do this like, between this week and next week, it should be like done. But I do think it's important to design it correctly, and because it does have implications on the actual kernel itself with this part, and so I think it is important to think it through. But I think we are basically converging on two solutions. Both of them are pretty trivial to like vibe code, and it's also not a lot of code. And so I think we're actually very, very close to having a solution. It took a long time to think it through, but I think this is one of those problems where it's like 90% of the work is just thinking and understanding the design space. And then especially with AI, like we can be done in like a couple minutes, unless frankly we can just do this. We can do at least one right now. So why should one learn C in 2026? I mean C is everywhere. C is very fundamental, and also C is important for understanding languages that build on top of it, like C++ or Rust, or things that sort of logically follow along with it. And also, if you understand C, you can understand the motivation between modern language features that C doesn't have, like optional in C++, or coroutines, or like smart pointers and stuff like this. So you get a bit of a better context around why languages are the way they are if you have experience with a language that's so bare bones as C. ChatGPT is cooking in terms of thinking about the whole program options. I agree. I think I'll have to say I think that was a really good analysis from ChatGPT. Especially if you only have 2 hours every week. Major employee vibes. Yep, guilty as charged. Yeah. So without further ado, let's vibe code the first one. And what I'm going to do, so what basically what we need to do is Claude. We don't want to accept Claude's plan. ChatGPT actually already has a great suggestion. So I'm just gonna say I agree with you about solving it at the config abstraction level instead of firmware config. I have please write a prompt that I can pass to my coding agent to implement this. Okay, so I'm gonna have ChatGPT make a prompt that I'll paste into Claude. Okay. Kernel.test. Okay. Okay, this is actually kind of a long prompt. Okay, maybe it's faster. Okay, I'm gonna kill the palm tree because we're getting kind of close to the end of time. This is kind of a long prompt. Okay. You know what? I am not going to directly use this. It's like a bit too much. And also, Claude already has a lot of context. I'm just going to uh, talk to Claude some more. In which case, I will use hyper. Okay, so I actually want to solve this in a different way. Instead of using this QEMU device, I would like to solve it at a higher level of abstraction. Let's generate liminy config files dynamically and kernel images dynamically as part of the test script. We can have a template liminy conf file, and then we will just generate one that has a single entry with a kernel command line that is configured to run a certain test ID. And then we will generate an ISO that bakes this config into the ISO. It doesn't require recompiling the kernel, only regenerating a new ISO. And then the script will run QEMU as usual. I'm just gonna, okay. I'm just gonna go with that for now. Okay. So I'm still in planning mode on Claude, and so it's not going to do anything, but we're just iterating on the plan. Should prompting be considered building? If NVIDIA is doing it, then yes. If it is building, I doubt that, since they're probably lying, since that's what they sell. Hi, worker, how much have you advanced? I want to write a report this afternoon about your performance on the project. You can leave it at my desk. To this question, I think it depends on how you prompt. I think prompting can mean a lot of different things. As you can see in our current way of working, we are prompting in a way where we as the engineers retain 100% understanding of what's happening. And I would totally consider that building. And even when we start generating code, we're still going to maintain 100% understanding of all the generated code. It's just helping us do that faster than we would otherwise. So let's read the plan. Chosen approach, solve it at the ISO level. Keep one liminy config template. The test script substitutes the test ID into it, regenerates the ISO, boots QEMU with the per test ISO, timeout 0, single entry means liminy boots with 0 interaction. Perfect. It has some context. Changes. Okay, so config template, limit test in, single entry config with a placeholder. Perfect. Factor the ISO recipe. Okay, interesting. Move the invocation from the build system into a small script. And that way we have this one place for the XOR invocation, and both the build system can invoke it, but then also the test driver can invoke it. So that sounds perfect. Test driver, right? Tests run test.sh, test ID, yep. Sure, artifact exists. Wait, what? To the configured presets build. Okay, interesting. Copy the staged tree to a tempter. Then template into replacing. Yup, looks good. Boot headless. Okay, let me see. All right, I see some discussion is happening about LLMs. I'm gonna keep locking in because I need to go somewhat soon. Stream output to a log while watching for markers on test pass. Kill QEMU and exit 0. On test fail, kill QEMU and exit 1. Run all mode, loops over the known test IDs and reports a summary. Perfect. Okay, so in general, this looks pretty good. I have a couple comments I'm gonna make on a couple of steps. So, for 5, I don't really love how it says stream output to a log. I mostly want it to just capture all of the output of QEMU. Yeah, I'll just make some edits. So re5, start. If it's simpler, don't stream the output, but just capture. Oh, I see. But this is sort of interesting because if we stream the output, we don't need to have a special mechanism that shuts down the VM because it'll just kill the VM if it sees this output. Otherwise, we need to have a way to shut down the VM with like this, there's like this QEMU feature for doing this. I'm gonna search quickly for this. QEMU debug ISA exit, I believe is what it's called. Wow. Dang, how is it that hard to find? This is the patch that does it. Debug. You can't, okay, and this is actually interesting. You can't use ISA debug exit in a non-x86 machine. ISA. So that's interesting because it has implications if I ever want to port my kernel to a different architecture, then this decision is relevant for that, because if I choose this, then then in the future, I'll need to figure out a different way. But the advantage of doing it this way is I don't rely on a architecture specific QEMU feature. For me, that's really significant actually. And so I'll actually say, let's go with this. I actually do prefer this. Then we don't need this specific feature for shutting down the VM. But what else? Okay, re4. For now, don't try to fill in to replace the panic. We'll do that later. Just do a log test passed. Okay, I'll just say, for now, just replace the panic with log test passed, and we'll fill in the actual test code later. Yeah, I'll just give it that feedback. What's up, black hole? I'll catch up on the chat in 1 second. I think I'm pretty close to letting the AI just rip on this thing. So yeah, okay. We're pretty close. We have this awesome plan. Replace with log test passed. Just enough to prove that into actual, okay. Yeah, I'm gonna sign off on this. I'll just say, like, looks good. Let's do it step by step. After each step, stop to check in with me. Okay. So we'll be watching it as it goes. Okay. I'm gonna go into auto mode. So now we just let it rip, and it's executing our plan. So here's this template script, or template config. Looks pretty good. Okay. Your interactive boot, and then kind of this unchanged, cool. Okay. Go. Great. So in the meantime, we can like clean some of this stuff up. Looks good. Okay, let's check out the chat. So people were talking about NVIDIA. How did you learn all this low-level stuff? I mean, I've been coding for a long time and working as a programmer, but in particular, I learned a lot of this OS development stuff by streaming for over 2 years now. I learned a lot of this just via streaming, but I've been also working in infosec and like embedded hardware for quite a few years, so I have some strong fundamentals. Okay, now that keeps the flag the same. All right, so let's take a look at this refactor. So we have this. So instead of just running this command right here, we just call this script xoriso, this exotic kind of thing. And I'm going to commit. This is a reasonable extract make iso.sh. Cmake, or I'll call it build. Okay, go. Yo, are you fully vibe coding, or do you actually know C++? I would say I actually know C++. Yeah, I'm only very minimally vibe coding. Yeah, I think that is how it should be for now. treating like a search engine, removes unnecessary fiction. Yep. I mean, I would go a bit farther than that. I would say I think it's legitimately useful to have it be an agent and like do things. It's just a matter of curating what you have it do and how much control you cede to the agent and how much understanding you cede to the agent. I'm trying to retain 100% understanding at all times. So that's my way of using it. Why would you think just because someone is vibe coding, they don't know how to program? I mean, I think these days it's a reasonable question. You know, people be vibe coding so much crazy stuff, so you never really know. What's up, Black Hole MX? ARM Mac, yes, I am. What features will your kernel support? Is it going to be for a specific use? Yeah, so these days it's looking like it's going to be a bit more real-time OS, like embedded style. So not really like a desktop operating system, more like a small OS you might run on like a microcontroller or something like that. Word. Okay, so I did some work. This is working. Let's check out this new thing. It's headless. It verified booting with guard page shows kernel command line and log. And kernel. Wow, it even like did some stuff. Let's check it out. Code review time. Okay, I'm gonna actually review this in my text editor. So run one kernel integration test. Okay, so here's a script. Test ID build dir. Okay. You need to pass it a flag. Okay, test ID build target. Cool. Timeout seconds. Okay, it even anticipated the timeout. Will run my washing machine on it when you release. Sick. Yeah, I was sort of thinking like, yeah, we can run it on washing machines. If anyone has like a vape they don't care about, we could try to run the OS on your vape. You know, like a small little device or something like that. Maybe like some AirPods. I don't know, something like that. Timeout's like, okay, cool. I mean, so yeah, like already this is way better bash than I would have ever written, but it also is violating Ismail's 10 lines of bash rule. So we could possibly do this in Python alternatively, but for now, we'll just go with this. It CDs into somewhere. That's kind of interesting. It makes a tempter. That's also interesting. I guess it's sort of unavoidable when we are doing this file generation stuff. I mean, this is, okay, interesting. Clean up exit. It removes the tempter. Okay. It triggers a build to make sure the kernel's up to date. I have a very good look at that. Yeah. I mean, it's getting that from make temp d, so I'm inclined to think that is fairly safe, but good call. So we build things, and here's where it gets interesting. We start to copy some stuff. We copy the ISO dir. So to be a bit more clear about what that means. So So the way this looks is, what was it? Kern boot ISO-dir. There we go. So the ISO-dir is where we prepare the file structure that XOR-ISO will package up into an ISO. And it has the kernel binary. It has this particular directory structure where it's like you're at the root, there's a boot directory, the kernel's inside the boot directory, there's a liminy folder, you put a bunch of like random stuff in that folder, including the liminy conf. And then you can pass this directory to XOR-ISO and it will make you an os.iso. And what we want to do is we just basically want to have a copy of this ISO-dir, and then we're just sort of like replacing the liminy.conf and sort of like stamping out different ISOs from this kind of like a template ISO-dir sort of thing. So we're copying the ISO-dir. We are replacing the command line marker with a test ID. And generating that into that exact position, in this temp directory. We generate the new ISO, os.test.iso, and console.log. So now we're going to execute QEMU. These are some interesting arguments, and apparently, and SG mentioned that earlier in the stream, you can pass file and log to, I guess it directs the contents of the debug port to a file. Interesting. I don't fully understand the args. Here are the ones that I'm using. It slightly modified them. I mean, there's no reason it's not using GDB. This log thing is sort of different. It is missing this SMP thing. So I think that's actually a question. I'm wondering if it's important. We need the SMP thing. Maybe it's implied that its sockets equals 1. And then, okay, now it is, wait. Okay, it runs it as a background process. And so that's like, that starts running. And so now the parent process starts to grep. It's like grepping this file. Then exit 0. And exiting triggers the trap which kills QEMU and cleans up the directory. Yeah, +1 for everything declared at top or in config file. Are you referring to these variables right here? Yeah, I like that too. Okay. Okay, then it's grepping for test failed, and it will fail. It will fail things otherwise. And then what's up with this? Kill 0. or QEMU exited. So this is the case where QEMU randomly exits before either of these texts have been printed. Which could, when would that even happen? Not totally sure. And then there's the final case where it's like, okay, the timeout gets triggered. And so the kernel went into some like weird loop for 30 seconds and will hang there forever. And this catches that case. So we basically just do a loop where we just sort of like check for stuff every second, basically. So yeah, let's take it for a test drive. Last piece, replace the panic with log test passed plus a halt loop. Ready, go. Okay, that's the last thing it should need to do. Then we should be able to take this for a test drive, and that will be the last thing we do today on the stream. All right, check that out. I'll actually replace this with a panic. I do love a good panic. Panic, test ID panic. Shouldn't get here. Okay. So we're getting pretty close to it. Let's check it out. So, oh shit, this thing was still editing the file, or was it? Okay, I'm going to, how do I, okay, I'm trying to quit this. Okay. Okay. Dope. Let's take it for a test run. So how do we even use this thing? The first thing we want to do, let's just build the kernel. Just like very simple, nothing special there. So now we've built the kernel. Now the idea is we want to have, we want to have a test to run. In this case, the command line that it's going to stamp looks like this: test test equals blank. So the actual string doesn't even really matter at this point because the kernel code is not even dispatching on the test ID yet. It's only just checking, was there any kind of test argument passed at all whatsoever? So that means it doesn't really matter what we pass. And so I should be able to do tests run test.sh, and I can even pass 0 arguments and get a help text. That's dope. And then I can pass a test ID, random test. And like I said, it shouldn't matter. And so I guess, what do we even expect to really see here? I mean, all it is going to do is exit 0 or 1. Okay, no, it does print stuff out. So I think it's gonna not really say a lot, but it'll exit. Oh wait, no, it says it'll echo pass, right? All right, let's just do it. pass. So that is interesting. We ran a integration test, and it would be, just for the sake of verifying this, it would be cool to disable this line and just say echo, and just so we can observe the temperature and check out what it looks like. So let's just run that one more time. And so now let's take a peep into here. So we can see a couple things. There's the isodr, which has this whole setup, and it is going to have this special one-off config that was generated. That looks great. That looks great. It's exactly what we need. It has this one command line. That's cool. We have a couple other things. So we have the console.log, which is the thing that's like has the output test passed. Very cool. Oh wait, then it panicked. Interesting. But it panicked because, of course it panicked. I mean, the kernel's code is just like, it prints test passed, then it hits the panic. The script is only pulling the output every second or so. And so of course, this is gonna have the panic text. So it's actually a mistake. It totally should get there, but then this is just, this is a different log. So that looks awesome. I'm gonna say that's a complete win. There's a couple other tests we can just do in the meantime. So let's, so now let's see a failure. And so we're gonna go with test failed, right? Because that is the test failed, right? It's grepping for the test ID. So now let's see a test failure. And same deal, but I've hard coded it to fail every test, and so we should see test fail, and it prints out a bunch of stuff. That's pretty cool. So one thing we should do, let's go back to the test passed. Also, just straight up, we got it working. So I have to celebrate a little bit for that. Yeah, this does very much appear to be working. But now that we have it prototyped, we can test how quote unquote slow this thing is. And so, we'll just do some, actually, let's make it a bit more professional. We're gonna use hyperfine. Dang, what? Command, echo 2. Okay, okay. Apparently, or maybe, oh, I need to do it like this. Okay, wait, what? So hyperfine is this benchmarking tool. Oh, do I need to, wait. I'm just passing the argument weirdly, I think. I need to do like this, maybe. Dang. Okay. What is the hyperfine command to run for this script? Hyperfine is this benchmarking tool. It's super awesome. You just give it basically like a random command line. Oh, dang. Every benchmark run leaves a 9 megabyte temperature. Good call on that one. Okay. Oh, I need to put it in quotes. Okay. So there we go. So the idea is to do some benchmarking. and see actually how long does it take to run a single integration test, because that's actually kind of important. And it seems like indeed it is not like that fast. It's pretty slow, to be honest. And so this data point is going to go right next to this slow card. So what we're seeing is it takes around 1.3 seconds to run a single integration test. Yeah, so that's not really very speedy. Ideally, you want your tests to run a lot faster than that. So like if we even have like 5 integration tests, that's going to take at least 5 seconds. Is it a profiling tool? I wouldn't say it's a profiling tool. It's more like a benchmarking tool. Mostly what it does is it just runs a command line like a bunch of times and times how long it takes, and then gives you like some nice statistics. I think you might be able to get some other data points, but primarily it's just about like how long did this thing take to run. Profiling is more like in depth. It's like if you want to see why a process is taking so long, the profile is going to show you like what stack frames, like what, which function is like super slow, what's your hot instructions, or like what function is very hot in the profile. So this is less detailed. It's just more for like, it's like a better time command basically. And so we can see that 1 second is pretty slow, but it's also not the end of the world. This would, yeah, but that's interesting. We could also prototype this second way, and my guess is that it would be a lot faster. I mean, it also might be possible to optimize this. Like what it's doing a file copy every single test run. And it's not even a small file copy. It's like 9 megabytes. So what I could even say right now is, great, let's optimize this. Simply you make the temp dir be in the build dir or wait a sec, maybe I'm not thinking. I'm just going to say simply reuse the dir if possible instead of copying the ISO dir every single time. E.g. hash. Maybe I didn't think this through, but the idea is just like, rather than copying the ISO dir every single time, which is probably the majority of how slow it is, what if we, like if you're running multiple tests against the same thing, you don't really need to copy like the kernel every time. I'm just going to give it this prompt. What I will do is I will stage this stuff. Not this actually. Whip initial integration test framework. Okay. So basically my main point there is like, yeah, actually, to be honest, it is pretty slow. A second per test is more than a second per test is much slower than you would really want. It's not a deal breaker. Like it's not a deal breaker, but it just means that if we accumulate a lot of tests, it's going to take like, like minutes or something like that to run the test suite. And you want to avoid that if you can. It's harder for integration tests, which tend to be slower than like super quick unit tests. But if it's all at all possible, you want this to be like way smaller than 1 minute or one second. So that is yeah. So yes. So it's doing some work there, not safe for concurrent runs. Interesting. It's applying a bit of intelligence around this. That's cool. And so just to point out, so now this is interesting because now we have added an additional dependency on the development environment for any developer that wants to work on this OS. Formerly, you just needed like some standard Unix tools. I mean, rsync is pretty standard, but it's not on the same level as like RM or something like that. And so that's a consideration for this particular implementation. But okay. .36 seconds, 2 changes. Faster pull. Oh, that's interesting. Which was most of the win. The kernel boots and prints. Oh, I mean, that's actually kind of obvious. I mean, if it's polling at every second, then naturally that's going to really slow down how fast it can react to things. Apparently, it also profiled this. I don't quite... yeah. Quick benchmark. Okay, I'm not quite... Can I... Oh, so it ran Hyperfine itself. That's pretty cool. What's left is roughly the CMake build, XRISO, and QEMU boot. Okay, so I think we can start to wind down the stream at this point. This is what I actually learned is that it's not, I mean, this is an improvement over the 1.3 seconds, but it's not amazing. So yeah, this is good to know. Not call it 900 milliseconds is approximately how long it takes to run a single unit test in the best case. I would expect, I mean, interestingly for this option, we still need to do some, I mean, obviously we're booting QEMU itself. We don't need to do, I guess, these first two. Maybe we want the first one. Okay. Anyway, I'm super excited. This is actually really cool. It opens the door to having a really, really awesome test suite for the kernel. Like, not only do we have our kernel lib tests over here, which are the unit tests, but we're also going to be able to test stuff that has historically just been tested manually by hacking the kernel main function for all these different things. Yeah, I always trade performance for simplicity, but my projects are not real world anyway, so that's probably why. Yeah. I mean, even for real world projects, I think a lot of times it makes sense to trade performance for simplicity. Yeah, for a lot of times, I mean, performance matters a lot less than you might think for a lot of for many kinds of applications. The code maintainability And understandability is worth way more than shaving off milliseconds or whatever. Not in all domains, but in some of them. Sensei, what is up? You are joining right at the end of the stream. But just a demo, we now have this super awesome, sick, yeah, super awesome integration test infrastructure. And as a final little taste test, what I will do is we can do this. Else, right? We'll actually start to interpret the test ID and dynamically behave based off of it. So let's just peep that real quick. So we're going to go for the passing test. As passed, we'll go for the failing test. Test failed. We'll go for the unknown. Unknown test. So that's sick. What is with the audio? What do you mean? You mean this stuff down here, or what are you talking about? Great stream. Thank you, Stefan. Appreciate it. Using Raspberry Pi man doesn't use Vim. There you go, code. Yo, okay, cool. Yeah, I'm gonna leave it here. Before I let you all go, quick sponsor read. What was it? Just what this stream is sponsored by myself. I want to talk to you about your challenges in the world of systems programming. I'm trying to figure out how I can be more helpful to my audience of systems programmers, and I would invite you to just contact me. I would love to hear about your challenges, whatever, whether they're technical, career, or otherwise. Here is my contact info, Discord, Instagram, email. Yeah, feel free to hit me up. I'm just trying to learn how I can be more helpful, so that's pretty much it. All right, y'all, that's gonna be it for today's stream. Thanks a lot for popping in, and I'll see you next week. All right, peace. All right, bye.